Hey there, Mr. Hearn here. Today we're looking at solutions and molarity. What molarity means is concentration, and it would be a really good idea if you started by watching the little mole video, which I'll put a link in the description of this one to that. Basically, I kind of work you through some vocab. This isn't going to do very well, is it? Where we look at things like solvent and solute and solution. So what those things mean. When you watch it, if you haven't already, you don't need to take notes on that. I'll cover the stuff in this video too. But then I talked about moles, which if you're in the class, we've already talked about all this stuff. But what we haven't seen yet is when the mole goes swimming. So the mole goes swimming, jumps into water. So just so you have the visual and what's going on, watch this video. You can stop the video when we get here. This is the stuff that I'm going to cover in this video. So where it starts being in front of the chalkboard, that's when we can call it good. Alright, so just to understand the vocab of things, a solvent. We're going to be throwing out the word solvent. The video has a lovely way for you to remember that. Water from event. The liquid that dissolves another substance. A solute is the substance that gets dissolved. Solution is a mixture of a solvent in a solute in a solvent. The solute completely disappears. So what we have would be water. We could have some salt that we put into water, and so when you end up, the solution is salt water. You can't see salt when it's dissolved. That's how you know it's a solution. If I have a solution, however much salt I have down here, I have the same amount of salt up here. It's all evenly mixed all throughout. So, if you're in my class, write this stuff down. These are notes for you. So hit pause and do that. Concentration. The overall idea with this is if you have more salt in the water, you're going to have a higher concentration. So concentration is how packed together the substance is. So when we had a whole lot of moles floating in the swimming pool, that was a higher concentration. When we had the same number of moles spread out more in an ocean, that was a low concentration. Right? So I guess more solute equals a high concentration. More volume of the solution equals a low concentration. And then the opposites are true. Less solute or low volume mean the opposite thing. Alright, so how we actually measure this is called molarity. Molarity is a way to measure concentration. The unit is a molar, so I'll say it's a 5 molar concentration. It's abbreviated with a capital M. You have to make sure it's a capital M. So if you've been in the math talking about moles and just writing M for it, that's not a good idea because you're going to get that confused. So mole has to be mole. You're going to abbreviate it as MOL. Molarity has to be a capital M. Otherwise, you're going to get very confused. Also, mass. If we threw in mass as a variable, that would be a lowercase m. We just write it in for mass. So, if I'm looking at molarity with a capital M, a 2 molar, as I would say that, a 2 molar solution is twice as concentrated as a 1 molar solution. So, more solute equals a higher concentration. That must mean I added twice as much salt. Or I could have added the same amount of salt, but to a smaller container. That's how you could look at it. So if you make the juice that's out of the can of stuff, so you take off the little zippy thing off the can, and then it's super concentrated there. You're supposed to put in 3 cans of water. If I only put in 1 can of water, that means I have less volume overall, and so that's going to be more concentrated. Okay, so molarity is, again, a measure of concentration. That's what that 2m means, or 1m. Molarity is from the moles of solute divided by the volume of the solution. And again, we're writing this stuff down in our notes. So that, in simpler terms for math, molarity is moles over liter, or molarity equals moles divided by liters. Again, you have to have it in liters. If you have it in milliliters, you have to take your milliliters and divide it by 1,000 to get liters. If you want to get the answer in milliliters, sometimes, because you'll have to know how many milliliters of water do I need. So you'll calculate stuff in liters. Liters times 1,000 will get you milliliters. So have these things handy because you'll use them a lot. Hopefully you just realize that if I have a number like 200 milliliters, dividing by 1,000 means you move the decimal 3 spots. 1, 2, 3. So if you just put a decimal in front of the hundreds place, it is 0.200 liters, if those are significant. So just move the decimal over in front of the hundreds place. To go the other way, if I have 0.5 liters, you move the decimal over 3 spots. That would be 500 milliliters. The sooner you learn how to convert liters and milliliters, you're going to save yourself a whole lot of stress. Okay, and again, if I'm going too fast, pause it, rewind. Stop stuff so you can take good notes. Go back over stuff again. Okay, so the molarity stuff is down here. First off, just the equation for molarity is written on the bottom of your mole sheet right here. It's a little bit separate, although lots of times we're going to come down like this and then come over on our steps. But it's a little bit separate than the rest of the roundabout, just because it's treated a little bit differently. For one thing, and you can write this on here, if molarity equals moles per liter, you have that triangle. So if you want to write this triangle on your mole sheet, you can. So it might be kind of helpful for you. And as you can see back and forth here, if I want to calculate moles, I'm calculating moles. What do I have to do with these two numbers to calculate moles? Because they're on the bottom, I'm going to have to multiply. That's what we're doing here. The liters times the moles per liter. Alright, so one thing, if on here, just to help yourself out, if you want to look at this, that is the molarity. So you can draw that on there. Molarity is the moles per liter. So sometimes you're multiplying it by molarity, sometimes you're dividing. If you flip your sheet over, you see the other side of it. It may be easier for you to follow at this point. We've been working with the unit canceling. That's why I showed you the fraction side first. But again, with your triangle, moles, molarity, liters. To calculate moles, you take molarity times liters. That's what this says here, molarity times liters. To calculate liters, you take moles divided by molarity. That's moles divided by molarity. So you work the triangle just like you used to. To calculate molarity, this is just the equation, moles divided by liters. So let's do some math with these. Just some simple problems working between these three types of units. So calculating with molarity. First off, a question could ask you, how many moles of salt do I need if I want to make 2 liters of 3 molar solution? In math, what does the word of mean? That's right, it means multiply. So they're almost telling you right here, you're going to multiply these two things. Okay? But looking at your mole sheet, how many moles of salt if I know liters and molarity? So looking at your mole sheet, I want to end up at moles. So I know my volume is 2 liters. I have a 3 molar solution, so that is 3 moles per liter. So 2 liters times 3 moles per liter equals 6 moles. The liters cancel out, leaving you moles. Or you look at your triangle, and that's what it would tell you to do. So 2 liters times 3 moles per liter equals 6 moles. So how many moles of salt do I need? If I want to do that, it means I take a 2-liter bottle or a stomach. I think they have about the same. No, they have different capacities. A 2-liter bottle or a stomach, but I have to put 6 moles of salt into that 2-liter bottle and then fill it up with water. That will make a 3 molar solution. Alright, next up. How many liters of 3 molar solution can I make if I have 6 moles of salt? So, how many liters of solution if I have 6 moles of salt? So we're going to end up at volume of solution. I'm starting right here with 6 moles. So, following this path, I take my 6 moles over nothing. My moles per liter, my molarity, I wanted a 3 molar solution. So in this case, I put 3 moles down here. 6 moles times 3, or times 1 liter over 3 moles. So you're dividing, which if you're doing the triangle, yeah, you figured out that's what you're doing. So 6 moles times 1 liter over 3 molar. Again, hopefully you're listening to this with some sound, because otherwise you can't tell what I'm writing. Equals 2 liters. Yay! Now with this, I'm using the same numbers every time, so if you did it wrong, you could see, like, wait a second, I had 2 liters earlier. But it all works out the same. Alright, last up, what is the molarity if I dissolve 6 moles of salt in a 2-liter solution? So, molarity equals moles per liter. And so that's not really a mole roundabout kind of a question. That's just a look right here question. So moles per liter. So that's 6 moles divided by 2 liters. And that's a 3 molar solution. Yay! So really it's just, for the most part, on these, just one step. I'm going up here, I'm going back here, or I'm doing that. But I don't have a scale that measures moles. I'm going to say that a lot, because you're going to calculate something in moles and then call that good. But I don't have a scale that measures moles. I have to measure things in grams. So all of this calculation just with moles doesn't really work out super well every time. We measure chemicals in grams, not moles. So sometimes we're going to have to turn things into grams. If a question gives you grams, for you to calculate all this mole stuff, if the question gives you grams, for you to get down here, grams is all the way up here. So if you have grams, you have to work through moles and then down. So instead of it being one step, you might have to do this in 2 steps, which after the rest of the conversion stuff we've been doing shouldn't be that horrible. So you have to turn it into moles first. If a question asks you to calculate grams based on a bunch of molarity stuff, if they ask you to calculate grams, they're working from down here. You have to go through moles, and then you just multiply by the molar mass. So because on both of these we need the molar mass, that's why for that homework assignment I said, go do the molar mass. Every single one of these, probably a good idea when you get started is calculate the molar mass of whatever chemical you're working on. Alright, let's move this guy up here. So, this is the type of question you're going to have on that molarity worksheet. The molarity worksheet isn't just grams and moles and liters, or just moles and liters and molarity. They do grams too. So, instead of asking how many moles of salt I need, it asks how many grams. What's the only way to get to grams? Grams is isolated up here in the corner. The only way to get to grams is to go through moles. So 2 steps. We're going to figure out moles first, then grams. So how many grams of salt do I need to make a 2 molar solution? So if I know I have to go to moles first, I'm going to take the volume, the 2 liters, times 3 moles per liter. So how do I know I'm doing that to get moles? Because that's what this step is. The volume times 3 moles per liter. 2 liters times 3 moles per liter to get moles. So I get hit equals now, but what's the point? I'm just going to keep going because I know I have now just canceled out liters, and so that means I have moles. How do I turn moles into grams? I need to know how many grams are in 1 mole. So if I'm working with salt, the first thing I should have done is salt is NaCl, so that's 23 plus 58 grams per mole. Or, sorry, 23 plus 35, so salt is 58 grams per mole. So I end up with 6 moles. Each mole weighs 58 grams, so really it's 6 times 58, if you want to look at it like that. So altogether, okay, so with that I get 348 grams. That's an 8. Sig figs, this has 2. The 2.0 had 2, 3.0 had 2. So everything had 2 sig figs, so I'm going to call that 350 grams of salt. Alright, so if any of that, if you didn't catch part of that, go back at the video, look at where I started again, look at where the things came from. Basically, I know liters, I have to work up and around. So the 2 steps I do are liters times molarity times molar mass. I like that one because it's all multiply. Makes it a lot simpler. Alright, next up. I want to see how many liters of 3 molar solution I can make if I have 350 grams of salt. So 2 things with this. If I know I'm looking for how many liters, I know the last step has to be going from moles to liters. That's the only way to get to liters. Also, because I start off with grams, there is one thing you can do with grams for the rest of the year, pretty much. The only thing you can do with grams is turn grams into moles. That is the only place it can go. So automatically, if a question gives you grams, just don't even think about it, just turn it into moles. It will work 99% of the time. That's what you're supposed to do. To do that, you need the molar mass. So a question gives you grams, automatically. What's the molar mass of the chemical I'm working with? So how many liters can I make if I have 350 grams of salt? So 350 grams I'm going to have to turn into moles. And then I take moles, according to this, moles times 1 liter over the mole. So moles divided by the molarity. So anytime you see this, that capital M really means moles per liter. So really it might be helpful every time you see that in a question is to replace it with moles over liters. So I'm getting rid of grams. So again, automatically with grams, anytime you see grams in a question, figure out the molar mass. I know 1 mole of salt weighs 58 grams. The molarity in my solution, 3 moles per liter. 3 moles per liter. If you need help, if the fraction version of this worksheet isn't working for you, you need a little bit of help, you can use this version of it. that just tells you exactly what math to do if you're kind of at that level. Hopefully you're a little bit higher to where you can do the fraction. It's a little tougher, but it gives you some benefits in the long run as far as being able to calculate stuff. So you end up calculating this out. It's 350 divided by 58 divided by 3. You would get 2 liters. Alright, so last question. What is the molarity? So molarity, automatically you're going to end up calculating the moles per liter. That's basically the final thing you're going to end up doing. What is the molarity if I dissolve 350 grams of salt in a 2-liter solution? So they gave me grams. What's the only thing you can do with grams? Turn it into moles. What do you need to do that? The molar mass. Okay, so again, calculate molarity. Really, molarity is its own thing. All you need to know is moles per liter. We know the liters already. That's going to be 2. So it's something divided by 2. I have to figure out how many moles there are, which again, that's all you can do with grams, is turn into moles. But by starting off with this equation, I know what I need to find. I need to figure out what number goes there. So 350 grams, I want to turn it into moles. So I'm going to replace it with moles. I cancel out grams. I know it's 58 grams in 1 mole. So it's 350 divided by 58. I'm going to just, off the top of my head, say that's 6. So what's the molarity? It's 6 divided by 2. So it's a molarity of 3.0 m, or 3.2 moles per liter. You can really unit, or put the unit on either way. Alright, so these 3 questions are the only types of questions you have on your molarity worksheet. So every question is going to be one of these. So if you have this all set up this way, you can go back in time before it was all scratched out and just match up what the question is in the worksheet to which of these it follows, and just look at how the units fill in and get you to the right place. So you do not have to do that worksheet. We're going to work on it in class. If you do the worksheet, get it done. If you think, wow, this is easy enough and I've got 5 minutes to kill, that might be all it takes you. Maybe a little bit more. And then in class, we have other stuff you can play around with for some A points. So otherwise, make sure next time you come with the molar mass of all of those things calculated up. So for instance, if it's KMNO4, you have to find out mass of K plus mass of Mn plus 4 times the mass of oxygen. So have those done.